Hey guys, my name is Shreyas and welcome to Simple Biology. Today we're going to be talking about bonding. Now in the previous video we talked about how atoms come together to form compounds, and that process is called bonding. And we're going to go a little bit more in depth in that. Now bonding is a very complicated process, and hopefully you had a review of this in chemistry. But if you didn't, go ahead and check out simplechemistry.org. Now, Simple Chemistry is a website dedicated for AP Chemistry instead of AP Biology, and you should understand how bonding works, but if you don't, I would highly recommend that you visit this website right here and actually watch the whole bonding unit that I have. I'm cramming all the bonding, everything on bonding in this small little video right here. But go ahead and check out this website if you've never heard of bonding before and you don't have a good chemistry background, because bonding is a important concept to understand. Okay, now there's two types of bonds, ionic bonds and covalent bonds. And ionic bonds is when are formed whenever there's a transfer of electrons between atoms. And what happens is since the electrons are transferred, you're going to create charged atoms, which are called ions, and that attraction between these charged particles or ions is a ionic bond. Now, let me go ahead and demonstrate that with an example. So, sodium chloride, which is NaCl, is table salt, and table salt exhibits ionic bonding. Let me actually draw this with a different color. So what's going to happen is that the sodium atom here, it has one valence electron, and the chlorine atom has 7 valence electrons. In the previous video, I mentioned what a valence electron is. A valence electron is the electron within the outer shell of an atom, and it's important to understand this. So sodium has 1 valence electron in its outer shell, and chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons in its outer shell. And what I'm drawing right here with this funny looking dots and stuff are called Lewis dot structures. And hopefully you know how to draw this. But if you don't, again, you can check out Simple Chemistry, and I'll have a whole video on Lewis dot structures, and that might be beneficial to you. Okay, so anyways, so the sodium atom has 1 valence electron, the chlorine atom has 7 valence electrons, and what's going to happen is that the chlorine atom is going to steal sodium's valence electron. It's just going to take it. So that's the transfer of electrons. So what ends up happening is that sodium is going to lose its valence electron, and then chlorine is going to now have 8 valence electrons. So it's going to have the original 7, and then it's going to have also sodium's valence electron. So what happens is now the sodium atom, since it's lost an electron, it's going to have a partial positive charge. Because again, the sodium atom consists of the nucleus and its electrons. And the nucleus has protons. I mentioned this in the previous video. The nucleus has protons, so the nucleus itself is going to have a positive charge, and that charge is balanced out with the electrons, which have a negative charge. Now, if the sodium atom loses an electron, that means the charge is going to become unbalanced, and now there's more positive charge than negative charge because of the protons, so the sodium atom is going to have a positive charge. Now, the chlorine atom, now since it has another electron, you can think of it as having more of a negative charge. Again, the chlorine atom also was balanced. This chlorine atom right here was also balanced in charge because the nucleus of the chlorine atom is positive and the electrons are negative, and those charges were balanced out. But now since the chlorine atom has one more electron, it's going to now have a partial negative charge. Okay. And the charge within this chlorine atom is now unbalanced. Now what happens is, since there's the sodium atom, now the sodium atom has become an ion. Okay, this is called an ion because it has a charge. and it's an atom with a charge. So since the sodium atom is now charged and has a positive charge, this sodium ion, and this chlorine atom has become a chlorine ion and it has a negative charge, the charges are going to attract. Since charges attract, since opposite charges attract, the positive charge attracts with the negative charge. That attraction is going to create a ionic bond, and then sodium chloride is going to be formed. Okay, so that's ionic bonding. Now, covalent bonding happens when there's a sharing of electrons. So covalent bonding is more prevalent in biology, and we're going to see it way more often than ionic bonding. And covalent bonding basically happens, is dependent on the valence electrons, the electrons in the outer shell of an atom. And what happens is that since atoms tend to want to have 8 electrons in their valence shell, and this is called the octet rule, they're going to start sharing electrons in order to satisfy the octet rule, and that sharing of electrons creates covalent bonds. So let me go ahead and demonstrate that with fluorine. So let's say we have one fluorine atom right here, and fluorine has 7 valence electrons. And then you have another fluorine atom right here, and this also has 7 valence electrons. Now each fluorine atom wants to have 8 valence electrons in its shell. So what's going to happen is that this fluorine atom right here is going to donate an electron. It's going to share 1 electron, and this fluorine atom right here is going to share 1 electron. So what happens is that they will each contribute 1 electron and then create a bond. This is a covalent bond right here. What I've drawn right here is a covalent bond. And now each fluorine atom has 8 valence electrons in its shell, and it satisfies the octet rule. So look, this fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine atom has 1, 2, 3, 4, 5, 6, 7, 8. So they satisfy the octet rule by sharing their electrons. And this is called a single bond, because each atom is only contributing 1 electron for the bond. So it's a single bond. Now, oxygen can also do this. Oxygen has 6 valence electrons, and then let's say there's another oxygen atom right here. Let me draw that with a different color. And that oxygen atom also has 6 valence electrons. So what happens is that each oxygen atom will contribute 2 electrons for sharing, and then there will be 1 bond right here, and then another bond right here. And now each oxygen atom has 8 electrons in its valence shell. Look, this oxygen atom right here has 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen atom right here has 1, 2, 3, 4, 5, 6, 7, 8. And this is a double bond. This is a double bond, and that's because each oxygen atom, is contributing 2 electrons to create 2 different separate bonds. So it's a double bond. Okay. Now, covalent bonding is special in that there's this interesting property called electronegativity. Electronegativity is when there's a pull of electrons in a bond by an atom. So what happens is basically one of the atoms within the molecule will pull on the electrons within the bond. And this pulling can either create polar bonds or nonpolar bonds. Let me go ahead and display that. Now, water demonstrates this. And again, I'm going to demonstrate these bonds with just little lines. Typically, covalent bonds are demonstrated with these little lines right here. And this hydrogen to oxygen bond is a single bond, and this oxygen to hydrogen bond is just a single bond. And what happens is that the oxygen is going to pull on the electrons within the bond. So you can think there's a pull of electrons by the oxygen, and that pull is called electronegativity. Now, so the oxygen is pulling on these electrons. Now, hydrogen is also pulling on these electrons, but not as much. Okay, so oxygen is pulling on the electrons within the bond. The oxygen atom wants the electrons, and the hydrogen atom also wants the electrons, so it's also going to pull on the electrons within the single bond, in the same case here too. But what happens is that the oxygen atom pulls on the electrons more than the hydrogen atoms, and that's how a polar bond is created. Now, a non-polar bond happens when there's an equal sharing of electrons. So here, in the case of oxygen, we just demonstrated how a double bond is created, and typically double bonds are drawn with these two lines right here like this. So what happens is this oxygen atom is going to pull on the electrons within the bond, but this oxygen atom right here is also going to pull on the electrons within the bond, and there's going to be an equal pull of electrons within the bond, so the two pulls kind of like cancel out. You can think of it like a tug of war. So since they're both pulling on the electrons within this double bond equally, there's an equal sharing of electrons, and that creates a non-polar bond. Now, the shape of the molecule determines if the molecule itself is polar or not. So if a molecule is polar, what that means is that the molecule itself is going to have a positive end and a negative end. So in the case of water here, since the oxygen is pulling on the electrons more than the hydrogen, the electrons are going to spend more time near the oxygen, and since electrons have a negative charge, then the top side of the water molecule is going to have a partial negative charge. Okay, and the way we write that is with this delta symbol, this Greek delta symbol, and then the negative to represent the negative charge. And that is, again, since the oxygen is pulling on the electrons, electrons have a negative charge, so if the electrons are all near the oxygen, then that top side of the molecule is going to have a negative charge. And the bottom side of the molecule is going to have a positive charge, okay, because since the electrons are being pulled more by the oxygen, what's being left here is just the nuclei of the hydrogen atoms. And since the nucleus of any atom is positive, and since these hydrogen atoms are losing their valence electron, the hydrogen atoms are going to be left with just their nuclei, and that nuclei has a positive charge, so each hydrogen atom is going to have a positive charge. And I hope that makes sense. You can always, again, visit simplechemistry.org. This video is meant to be a review of bonding, but if you've never heard of bonding before and you feel still weak on this after watching this video, I would highly recommend that you check out simplechemistry.org if you have the time to, and actually watch the whole bonding unit that I have there.